The fine feed wheels on these Chinese mini mills are honestly a pain to use. They're tiny, there's no crank handle, and they don't allow for a smooth or continuous feed rate. You constantly have to shift your grip on the wheel, which results in a bad surface finish. And to make matters worse, the measuring dial isn't even intuitive. It's basically useless for setting a depth of cut directly. Why? Because it's calibrated in 0.025 mm per tick. The major tick marks show every 5 of these, so they're spaced at 0.125 mm. Not exactly a clean metric group. When your cut depth needs more than a few ticks, out comes the calculator. You figure out the number of rotations plus the leftover ticks. And if you think you were safe with the calculator, the mini mill gets the last laugh, because the dial on the table uses 0.02 mm tick marks. It's a recipe for mistakes. All too often, I end up mixing 0.025 and 0.02 in my calculations, and that is how you ruin a workpiece. What can be done to solve this? I thought maybe the imperial system would help, but nope. Each stick is 0.984 thou, and a full turn is 59.0551 thou. Not exactly helpful if you're aiming for any kind of precision. So, what can I do to be able to set the depth directly without having to do math first? The fix? Simple. Regroup the tick marks. Make major ticks every 4 minor ones. Now you've got easy 0.1 mm increments. No calculator needed. So I made my own solution. It's got minor ticks every 0.02 mm and major ticks every 0.1 mm. A full turn is still 1.5 mm, but it's now super easy to track the depth. So long, slide rule, my trusty old calculator. The dial can even be reset to 0 for easy tracking. And the handwheel? Big diameter, deep dish design. Perfect for smooth two-handed feed. Plus, there's a crank handle for quick height changes. If you think this is a great idea, give it a thumbs up by clicking the like button. I'll be tracking which idea are most popular and sharing results in a future video. Now, let's take a closer look at the parts that make up this fine feed wheel. The measuring dial mounts onto the wheel with a bench spring that gives it just enough friction to stay put, but still lets you reset it. The crank handle is mounted with an Allen bolt and nut, so it spins freely. I have extended the existing axle with a threaded extension and milled a keyway slot. The mounting block holds the axle securely in place using 2 bearings, keeping everything solid and aligned. Then the wheel slides on with the keyway and gets bolted down. Finally, the cover plate fits neatly under the belt drive's base. With that problem solved, I've got more ideas on the way. Check out the next idea by clicking the link on screen. And don't forget to subscribe if you want to see more like this. Thanks for watching. I hope this idea comes in handy in your own DIY workshop. See you next time.